everybody, and welcome to this video on functions. In this video, we're having a look at inverses and specifically the inverse of a straight line graph. Now, as we have mentioned in the previous video, an inverse is a reflection of the graph about the axis, about the line y is equal to x. So over here, we have f inverse in orange and f in blue, and we then have the inverse. So the inverse of a straight line is still a straight line, and that's unique to a straight line. And also what you should notice is whatever used to belong to x of the original graph now is for f inverse. So if we have a look at the intercepts of f, the y-intercept is 2 and the x-intercept is 4. Because it's reflected about the line y is equal to x, that now becomes that the x-intercept of our inverse is 2 and our y-intercept of our inverse is 4. So you can see the positions has swapped around. Whatever used to belong to x now belongs to y, and whatever used to belong to y belongs to x in our inverse. The domain of f being a straight line, is x is an element of real numbers. The range of f is y is an element of real numbers. The domain and in range of the inverse is x is an element of real numbers and y is an element of real numbers, which is still the domain of the straight line, since the inverse of a straight line is still a straight line. So let us do an example to help us understand. We have this g of x being equal to 3x minus 6. Let us plot this graph and then go ahead and find the inverse. So to plot this graph, and please watch our videos on the straight line graph if you're unsure, is first we get our intercept. So x-intercept, we make y equals 0. So we have 0 is equal to 3x minus 6. 6 is equal to 3x. And finally, x is equal to 2. So our x-intercept is 2 and 0. We then go on and find our y-intercept. So our y-intercept, we make x equals 0. So we have y is equal to 3 times 0 minus 6, which is simply minus 6. So our y-intercept is 0 and minus 6. So that is our original graph. Let us quickly plot it. So I'll put the axes over here. And so let's just put some labels. One, 2, 3, 4, 5, 6. Go up to 6 on all sides. And please do it according to scale so you can really see the impact of the inverse. This here is not 100% according to scale, but you with your ruler and everything has no excuse. Okay. So our original graph has our x-intercept being 2 and our y-intercept being negative 6. So we're just going to join those 2 points. Okay. Let's just make it actually go through those points. Okay, so there is our graph f. Sorry, it's G this time. So there is our graph G. Now let us go and find our inverse. So reminding you about the rule on how to find the inverse from the previous video is for the inverse, the rule is to swap x and y and solve for y. Okay, so in the place of y, we're going to then put x. is equal to, and in the place of x, we put y. So can you see this y is equal to 3x minus 6? We've swapped the x and y. So in the place of y, there is now x, and in the place of x, there's y. So now let's make y the subject. So we take over the 6, and then we divide both sides by 3. So it's a third x plus 2 is equal to y. So our inverse we represent with the -1. G of x is then equal to a third x plus 2. What we can now do is find our x-intercept and y-intercept. So it's a straight line. So for our x-intercept of g, we make y equals 0. So we have 0 is a third x plus 2. And then we have -2 is a third x, multiplying both sides by 3, we get x is -6. So our x-intercept is -6 and 0, and our y-intercept, we get x is equal to 0. So we have y is equal to a third times 0 plus 2, which is 2. So our y-intercept is 0 and 2. I would like to point out that if you have a look at our x-intercept of our original graph, it is our y-intercept of the inverse. And if you have a look at our y-intercept of our original graph, it is now the x-intercept of our inverse. So let's plot our graph. So our x-intercept is -6 and 0, and our y-intercept is 2. So again, joining those 2 points, I don't know if I can do it really well. Okay, I think that's more or less good enough. And there is G inverse. And if you have drawn it properly and according to scale, what you should notice is it should be symmetrical about the line y is equal to x. So as you can see, whatever used to belong to x now belongs to y, whatever used to belong to y now belongs to x. Let's wrap up the section by talking about the domain and range of G and G inverse. So the domain of G, it's a straight line, so it's x is an element of real numbers. The range of G it's also a straight line, so it's y is an element of real numbers. The domain of G inverse is a straight line, so it's x is an element of real numbers, and the range of G inverse is also a straight line. It's y is an element of real numbers. Please have a look at this example again if you have not understood it. It is very important. If you have, please look at our other inverse series on the functions.